Hello students, here is Shitu, your mathematics teacher. This video is brought to you by IOTA Virtual Learning. In today's tutorial today, we are going to be solving WAEC questions from graph of linear and quadratic function. So I want you to stay focused and see how we are going to do this. We have this first example 1 and example 2, and this is a graph of a quadratic equation. So anytime you see a curve like this that looks like U, okay, it is called a curve of quadratic equation. So now here the question says use the graphs below to answer questions 1 and 2. So we have the question 1 and 2 down here. So we have it here, right? We have 1 and we have what? We have the 2 here. So now the question says what is the equation of the curve? So now the curve up there, this one that looks like U here, the one that looks like U that is facing down here is the curve they are talking about. So that is what is the equation, okay, of this curve, okay? We call it parabola. Then also the second question says that which of these equations best describe the point of intersection of the curve and the straight line. So we have this, which of these equations describe the point of intersection between the curve and the straight lines. Pause the video, okay, check the graph very well, check how the connection, the connection between the straight line and the curve. Then also look at the question very well. Then you have to solve this yourself, okay? Then after that you can come back and see how it is solved here. Okay, so we have this now. So on the graph we can see we have what? We have the curve and the straight line, this straight line here, okay, and the curve here. So we want to know the point of intersection now. So from this graph, so we can actually bring out the curve of intersection. Now for the first equation that says what is the equation of the curve. So therefore if you want to know the equation of the curve, if you want to know it from here, we are going to locate a place where this curve and the x-axis, this is x-axis here, where this curve and the x-axis meet. From here, or from the two ends, you can see here we have what? We have this to be -3, that is x equals what? S equals -3 here, and for this place we have x equals what? S equals 1. So that is the point of intersection we want to know. And for the number 2, question 2 that say which of these equations, so we are going to look at the point of intersection between the curve and what? And between the curve and the what? And the straight line. So now we go to this graph. You can see this curve here, okay, and this straight line here. So for this place we still have x -3, and here we have what? We have x. If you trace this x up here, you can see that we have what? We have 2. So therefore we have the x there to be what? X is 2. Are you following now? So these are the points we are going to use here. So now for the first one, so it means that the root of this equation, which is the solution of the curve, the root of the curve is x equals -3 and x equals what? X equals 1. Are you getting it now? Now we have this root of the curve here. So therefore we are going to, that means we have the roots now. Now we want to know what will be the equation for these two roots, that is x equals to -3 and x equals 1. So let me put it down here. So we have x equals -3 and x equals 1. Okay, so what we are going to do now is that we are going to write it in a factor form. So to write it in a factor form, we are going to take this minus 3 to the left hand side, we take 1 to the left hand side here. So therefore this is going to be x minus 3 going to the left hand side, it will change to positive. You have x plus 3, we write it as factor like this. Then multiplying, we do the same thing here, writing it as factor x. This one is coming down here, is reaching to negative. Then we are going to equate it to be 0. That is, when we multiply this and this together in a factored form, we must have something like this here. Okay, but here we're going to have x times this is going to be x, because we want to use this to multiply this, x squared. That is x times x, we are going to have x squared. X times minus 1, we are going to have minus x. 3 times x, we're going to have plus 3x. Then plus 3 times minus 1, we're going to have minus 3, then equals 0. Right, so we are going to have x squared minus x plus 3x, we're going to have plus 2x, then minus 3 equals. Now since we have 0 here, but we want to find this 0 here, we are going to change it to what? To y. So we're going to have y. So therefore we have the solution to be y. It can be y equals x squared plus 2x minus 3. So now looking at this, when you look at these options there, you can see we have x squared plus 2x minus 3, x squared plus 2x minus 3. So which shows that this option C is our solution. Do you understand now? So now let's go and look at the other one. They said the point of intersection. This is the point of intersection between this curve and what? And this straight line. So for here, we have what? We have this to be x minus 3, and here we have x to be what? X to be 2. So the same approach we are going to use, right? So we have x minus 3. Down here we have x minus 3. Okay, x equals minus 3, and x equals what? X equals 2. That is what we have. Okay, for the point of intersection between the straight line and what? And the curve. So therefore the same thing we did here, we are going to do here now. So we are going to write this as factor form by taking minus 3 to the left hand side like this. This one also to the left hand side. So this is going to be x plus 3. We write it as factor form. This will come in x minus 2, then equals 0. Okay, so now here we're going to have, open the bracket, multiply this by this, x times x, we have x squared, x times minus, we have minus 2x, 3 times x, we have plus 3x, then 3 times minus 2, we have minus 6, then equals 0. Are you following? So now from there we have x squared plus 2x plus minus 2x plus 3x, we're going to have plus x, right, then minus 6, then equals 0. So now we have the what? We have the equation as x squared plus x minus 6 equals 0. So now let's check our options there. We have x squared plus x minus 6 equals 0. So therefore we have option C to be the solution to the problem. Okay, now if you find this interesting, kindly check your past questions you have with you, solve the problems that are related to this. Okay, thank you. This is the question 3 on the graph of linear and quadratic function. So we have this function, so we are improvising this as this is a graph. Okay, so where we have y-axis and we have x-axis. So now we have the question down here that the graph of the equations y equals 2x plus 5 and this are shown using the information above, okay, in the graph. Okay, so we want to find the point of intersection of two graphs. Okay, so we have the points here. So I would like you to pause the video, look at the graph we have above. Okay, then find the point of intersection of the two graphs. So now, as you can see, we have this graph here. This graph comprises of two we have this is a curve, which is a quadratic curve, and we have a straight line. This is a straight line here. So therefore, we want us to know the point of intersection between this curve and this line here. So which means where the two curve intersect. So we need this point here because that's where they connect. That's where this point here. We also need this point here also. Okay, so we want to know the coordinates. Okay, so now if we want to know this place, this is what you are going to do. So this is y-axis, that is any value of y we can have will be coming from x-axis, and any value of x will be having here, so it will be coming from x-axis here. So now what we're going to do is that from here we are now going to trace this one down here. If you trace it down here, you'll see that what we have our x to be 2. So here we are going to be having 2 comma. So now we trace this one. Let me use my ruler. So you trace this one, okay, from here. You trace it from here down to the y-axis like this. Okay, as we can see, so anything that we found here, since this is 10, anything that we find here, so it's going to be around 9. So we have 2 comma 9, okay, for this one here. Then the second one we are going to look at is this place here. We're going to trace this from here down to x-axis, then also I will trace this one down to what? Down to y-axis to know the value of what? Y. Are you following? So this is what you are going to do. So now from here, so we can see around this place, this is going to be, so this place we are going to have this coming down here is going to be minus, that is negative. So we're going to have minus 1.5, okay, that is from x, and we're here, so we're going to have something around the 2. Okay, we have something around 2 here. Okay, so definitely it's going to be minus 1.5, then 2.0. Here is 2.0 and 9.0 ordinarily, because we are having 2 and 9, so it's still the same thing as 2.0 and 9.0 here. So now let's look at this. These are the points of intersection between what? Between the two curves. So now let's go down and see whether we are going to have this as options. So we have 2, 9. Let's look at this. We have 2.0, which is the same thing as 2, 9 here. Okay, then we have minus 1.5, 2.0. Okay, so let's look at the rest. We have 2.0, 8.5, minus 1.5, 2.0, 2.0, 8.0, minus 1.5, 2.5. So now 2.0, 7.5, and minus 1.5, 2.5. So which means the one that corresponds, with what we have in this graph is the one that is the option A. Are you getting it now? So thank you so much for watching. So this is from graph of linear and quadratic. Okay, so find more of this question so you can practice more. Thank you so much for watching. Bye bye.